Hi guys, so in this video we will be discussing the questions you have as part of topic 3.1. So by this stage you should have completed these questions on your own and you should just be marking your own answers and seeing where you can fill them in. Okay, so the first question asks of us, explain why noble gases tend to not react. Now, I remind you that noble gases are found in group 18 of the periodic table. Okay, now let's talk about what is needed for an atom to react. Well, we said that reactivity is related to the electron configuration. Now, noble gases have full valence shells. They've got a full outer energy level. So therefore, they are stable because they have sufficient amount of electrons in their valence shell to be stable. They've got full outer energy levels and therefore they do not react. So why do noble gases not react? Noble gases, we can say, have full outer energy levels. They are stable and therefore inert. If we now go on to question 2, they ask where are the valence electrons located in an atom? They are located in the outer energy level, furthest away from the nucleus. Okay, how does a cation differ from an anion? Cation is formed by the loss of electrons they are positive, whilst an anion, I don't have enough space, is formed by the gain of electrons and therefore negative. So if we look at number 4, it says write down the octet rule in words. So the octet rule is defined in our notes as a concept of chemical bond theory that is based on the assumption that atoms tend to react to either have empty valence shells or full valence shells of 8 electrons. And remember that octet refers to 8. Okay, so that's where the octet comes in. If we go to question 5, it says write down balanced chemical equations to show how the following atoms can react to achieve a noble gas configuration. Now, the first one we have is iodine. Now, guys, I want you to remind you that iodine is a diatomic element. That's how we find it, as a diatomic molecule. So we find it as I2 in nature. Okay, so if I have two iodine atoms, what will happen with them? What type of ions does iodine form? Is it a metal or non-metal? Okay, it's on the right hand side of the periodic table, so it's a non-metal. We said non-metals tend to form, that's correct, anions. So anions is the gain of electrons. What is the charge of ions in group 17? Okay, it's 1 minus, yes. So if I want iodine to have a charge of 1 minus, and I'm going to have two iodide ions, that's what we call the ions, iodide, it becomes a D, okay? So if I'm going to have two iodide ions, I need to gain two electrons, one for each of my atoms, okay? The next one we have is strontium. And strontium, if you go to your periodic table, is in group 2. So group 2 elements tend to form ions with a charge of 2 plus. And for it to have a charge of 2 plus, it must lose 2 electrons. So it gives 2 electrons away. So this would be my equation. Then I've got nitrogen. Now nitrogen, guys, is once again a diatomic element. We find it as N2. So in other words, it's in group 15. So because it's in group 15, what is the charge of a group 15 ion? Okay, it gets a charge of 3 minus, or in overall -3. It would have to add 3 electrons to get to -3. So the charge, I just want to correct that, would be 3 minus. Okay, so N2, if I've got 2 nitrogen atoms, I would need not only 3 electrons, I would need 6 electrons for both of them, so that they could have 2 nitride ions with a charge of 3 minus. So we say these are nitride ions. Okay. Then oxygen, also diatomic, O2. It's in group 16. If it's in group 16, it wants a charge of 2 minus. To get a charge of 2 minus, it means each of my oxygen atoms need to accept 2 electrons. So in total, I will have to accept 4 electrons to have 2 oxide ions. Okay, then we've got sodium. Sodium is group 1. Group 1 forms ions with a charge of 1 plus. So sodium will become a sodium ion. How? By giving away 1 electron. Our final one is aluminium. Aluminium is in group 13. Group 13 forms a charge of 3 plus. So to get a charge of 3 plus, my aluminium atom must give away 3 electrons to form an ion with a charge of 3 plus. So those are my equations. Take note of the non-metals where they become an ide if they form ions. If we move on to question 6, they say, which noble gases electron configuration do the following ions have? Now, normally, lithium would be 1s2, 2s1. It will only have one valence electron. When it forms an ion, if it becomes lithium plus, what happens? To become lithium plus, it loses this 1 electron in the 2s orbital, so it becomes 1s2, which is similar to the noble gas configuration of helium. Okay, magnesium is magnesium 2 plus when it forms an ion. Normal magnesium is 1s2, 2s2, 2p6, 3s2. So its valence electrons are those in the third energy level. If it becomes magnesium 2 plus, it gains an electron configuration of 1s2, 2s2, 2p6, which is similar to the electron configuration of neon. So that's my answer. Then fluorine. Fluorine as a, if it becomes a fluoride ion, fluorine as an atom is 1s2, 2s2, 2p5. It just needs one electron. So it gains that one electron to become a fluoride ion with an electron configuration of 1s2, 2s2, 2p6, which is similar to the one above, which is the electron configuration of neon. Silicon has 14 electrons, so if it becomes a silicon ion, it goes from 1s2, 2s2, 2p6, 3s4, and if it's becoming 4 plus, it means it's losing those 4 electrons. So the silicon 4 plus ion is 1s2, 2s2, 2p6, which is similar to that of neon. And then sulfur, the sulfide ion. So sulfur is normally 1s2, 2s2, 2p6, 3s6. No, 3s. I've made a mistake in these last two. So let's just correct that, guys, because no one even stopped me. This one shouldn't be, let's just correct the last two. So it should be 2p6, and then it should be 3s2, 3p2. And it will still become, if it becomes a silicon ion, it will still be 1s2, 2s2, 2p6, losing the last 3, which is similar to that of neon. And then the sulfide ion, sulfur, is normally 1s2, 2s2, 2p6, 3s2, 3p. Up until there, we had 10, 3p, 4. And then it will become a sulfide ion, 2 negative, by gaining 2 more electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, which is similar to that of argon. So it gains the electron configuration of argon. Then question 7 says, why do chemical properties of an ion differ from those of its parent atom? Okay, what determines chemical properties? Chemical properties are determined by electron configuration. So if it's determined by electron configuration and we've got different electron configuration, we will have different chemical properties. Okay, so that's the reason why it will differ. And remember, the ions will be much more stable and react much more like our noble gas atoms. Moving on to our final question, they say, explain why alkali metals are extremely reactive. All alkali metals only have one valence electron. And what do they do with those valence electron? They lose it to gain noble gas electron configurations. This requires a small amount of energy. And therefore readily happens. Okay, so those are the answers to the questions of topic 3.1.